Hi, and welcome to section 2.2, differentiating products and quotients. This is our last section for exam 1. So we've got just 2 more rules. I will give them both on the exam. So again, it's not about memorizing the rules, but being able to know when to use them and how to use them. So the first rule is the product rule. And that's exactly for when we have a product or a multiplication inside a derivative. So here's the abstract rule. If you've got a product, u times v, where u and v are 2 functions, when we take the derivative, we do take the derivative of each part, but not simultaneously. Notice that we take the derivative of the first part, the u, times the second part, plus the first part, u, times the derivative of the second part. Sometimes I just give it in this format without the extra brackets, so it's a little cleaner looking. So the derivative of a product, u times v, is u prime times v plus u times v prime. Recognizing when to use the rule, each part in the product, the u and the v, will have a variable, an x or a t or whatever the variable is that we're working with. So not something like 3x squared, where that is a product, 3 times x squared. We already know that we can just take the derivative of that and multiply the 3, 6x. You could use the product rule, but the derivative of the 3, when you get around to it, would be 0. All right, so let's start right in. Example number 6, find the derivative of f of x equals this product, x squared plus 7 times x squared minus 5. And you might think, oh, I could just multiply that out and never have to use the product rule. And while that's true for this problem, the problems will get harder. And so you still will pretty much be forced to use the product rule at some point. So let's use it on an easier problem. All right, so labeling as up above, we've got our u is the x squared plus 7, and the v would be the x squared minus 5. So I always like to do a roadmap of what I'm going to do to help keep me on track. So I'm going to take the derivative of the x squared plus 7. So I'll mark that I'm going to do that with my brackets and the little prime mark. And then I'm going to leave the x squared minus 5 alone. And then there's the plus sign that's in the rule. And then I'm going to leave the x squared plus 7 alone and multiply by the derivative of the x squared minus 5. In fact, I think I'm going to put those brackets and the derivative marks in red just to help them stand out. That's where the actual derivatives will happen. So here we go. Notice I gave my derivative a label, f prime of x. So derivative of x squared plus 7, we know from the last section, is just 2x. The 7 is going to disappear. It's a constant. And then that needs to multiply the x squared minus 5. And then plus, we keep the x squared plus 7 times, and again now the derivative of x squared minus 5 is also 2x from the x squared, and the minus 5 goes away because it's a constant. So all we have to do now is tidy up. The derivative is done. Now we just have to tidy up, my technical term, for things like distributing. So we'll distribute the 2x, each of those 2x's into their own sets. So we get 2x cubed, right? 2x times an x squared, 2x cubed, minus 10x, plus, and then 2x times x squared is another 2x cubed, plus 14x. And now I can combine like terms. I've got a 2x cubed plus another 2x cubed, and I've got minus 10x and a positive 14x. So I'll combine those and write a final answer. F prime of x, giving my label, is equal to 4x cubed plus 4x. Looks like negative 10 and positive 14 would give me a positive 4x. And it will be important later to be able to factor this, a common factor. So we could take out a common 4x, leaving behind an x squared plus a 1. Which doesn't factor any further. So if you'd like to factor your answers, you're welcome to do so, and we will need to do so after this exam in chapter 3. All right, or actually later in chapter 2 even. So now let's do another problem, number 22. Find and interpret the derivative of f of x equals the product of x squared plus x minus 1 and 5x minus 7. So notice that product, parentheses side by side, and we're going to find the product rule derivative, and then we're also going to plug in and just remind ourselves what it is we're doing when we find a derivative. So here we go. I'm going to write out my plan of attack. F prime of x is going to be the derivative of x squared plus x minus 1. Again, you could think about multiplying out, but in the long run, you'll be better off learning the product rule. So the first derivative of the first part times the second part, and then plus. Now we leave the x squared plus x minus 1 alone, and we multiply that by the derivative of 5x minus 7. And I don't mind, as you get more comfortable with derivatives, if you skip this step and just go straight to your derivatives. I'm okay with that. But you gotta be good and you gotta do it correctly, right? So don't skip steps if you mess up. All right, so two terms with x's inside here, x squared plus x minus 1. I'm gonna have to put parentheses around this because I'll get a 2x as above, and then plus a 1 from the x, and then the minus 1 goes away. All of that has to multiply the 5x minus 7. On the second part, I have my x squared plus x minus 1 times just a plain old 5. From the 5x, the 7 goes away. So we have some multiplying to do. Again, the goal here is now, we're finished with the actual derivative. I need to tidy up. So I'm going to FOIL out the first set of multiplying of the two binomials, and I will distribute the 5 in the second part. So let's see what we get. 10x squared minus 14x plus 5x minus 7. Again, feel free to skip a step here and there, but if it's incorrect, it's hard for me to give partial credit. Plus 5x squared plus 5x minus 5. And I'll also make the comment that I do give partial credit. So even if you've messed up, little tiny mistakes like a lost sign or whatever can really affect your numbers as outcomes, but if it's a small mistake, you don't lose as many points. All right, so for a final derivative of f prime of x, combining like terms, I've got 10x squared plus 5x squared, so that's 15x squared. Then I've got minus 14x plus a 5x and plus another 5x. So altogether that gives me minus 4x. And then I've got minus 7 and minus 5. Combining those gives me minus 12. Feel free to try to factor that. I'm not even going to try because that's not the point of this particular problem. Remember, we were going to evaluate it at x equals 2 and then make a statement about what that means. So f prime of 2, the derivative of f evaluated at 2, would be 15 times that 2 squared. Order of operations, remember square first, doing it out. 4 times that same 2 minus 12. And I'm going to go get my calculator. And I get positive 40. So I have found the derivative of f of x at 40. So that was one of the instructions. Find the derivative at x equals 2. The derivative at 2 is 40. And then to interpret it as the input x increases by 1. And so let's be specific, from x equals 2 to x equals 3, just always being as specific as possible to be clear. The output of f will, and I can be specific and say increase because this is a positive number, 40. So it will increase by approximately 40. And that would be the interpretation. All right, so when I do ask you to do this on the test. So finding numbers, it's one part, and then actually being able to make a statement about what those numbers mean. All right, and I think I will pause there and we'll come back with part 2 for the quotient rule.